Welcome back to the CAMX Demo Zone, brought to you by Composites One and the Closed Mold Alliance. The demo we're starting right now, we're going to be doing an epoxy infusion of a carbon fiber braided preform. So we're going to go through the steps of how we make the preform. We'll transfer it to our production tool, and we'll infuse the part all during the demonstration. And we have a temperature-controlled mold, so we can get a really fast cycle time on our epoxy infusion. So I want to go ahead and introduce our demo team. My name is James Jones. I'm the lead technical support manager with Composites One. I'm joined by our supplier partners as well. From A&P Technology, we have Brandon Strominger. And from Polytek CPD, we have Tom Augustiniak. And then for tooling, from Origen, we have Adam Elsmore. So why are we interested in preforms? Basically, with preforms, we can precisely position the fabrics and fix them in place. We don't have to worry about any resin outlife, like if we were using prepregs, no working time issues if we're using liquid resins. The preform has a heat set binder. You'll learn a little bit more about that from Brandon. But it makes it very good to stabilize the fabric on vertical surfaces or even complex patterns. This dome shape we're doing, it looks fairly simple, but it's actually a pretty complex shape to conform a fabric to. So the binder is heat activated. So what we're using today is we have a silicone vacuum bag with an integrated resistive heater. And so that'll heat our preform to the activation temperature, which is about 200 degrees. And then that will set the binder, and then the preform will maintain its shape. So we can lay up several heavy plies on complex geometry and create a preform. And these preforms are good for many different processes, including vacuum infusion, Vartum, high pressure RTM, and others. One of the other things you'll notice, this orange tool that we're making the preform on is a fairly low-cost form for making production tools. It just has to resist the temperature that we're forming the preforms at. So we can make the preforms off of our, we're not making them on our production tool. We can make them on a low-cost tooling and then transfer them to our production tooling. These preforms can be nested together depending on the shape for easy shipping. They could be made off-site and then shipped to the production area. So the preform is made of braided carbon fiber. We have several plies of a 540 GSM carbon fiber material. And this particular material can conform to complex geometry without having any cuts or darts in the material. And to tell you more about the material we're using, I'd like to introduce Brandon from A&P.
The reinforcement we're infusing today is a product that we call Qiso. This is a product produced by A&P Technology, or located in Cincinnati, Ohio. Qiso is a really unique reinforcement. It's a braided triaxial carbon fiber fabric with fiber orientations of 0 degrees off the roll and then plus and minus 60 degrees all in a single layer. So what that means is you have a quasi-isotropic structure all in a single ply. Applied to our Qiso today is a powder binder. This powder is from Westlake. It's an 05390 uncatalyzed epoxy binder. The fact that it is uncatalyzed is great because you don't have to worry about outlife or keeping it cold. And then the fact that it's an epoxy chemistry means that it will still mold into your resin matrix after infusion. So it's used today as mainly a preforming tool, as James mentioned, so we can heat this binder at about 200 degrees Fahrenheit and tack multiple layers together, and also start to build shape in as well, to start preforming this fabric offline, which is great because it frees up your infusion tool to just do infusion, and we can make these preforms offline and transfer them onto the mold tool when you're ready to infuse. The Qiso material itself is a really unique material. As I said before, it is quasi-isotropic in plane, but it is also balanced and symmetric in a single ply. So what that means is you can actually cure single ply laminates out of Qiso that don't warp or potato chip, which is great to keep dimensional stability of your part. It's also a multi-axial material that is still highly drapable, and that's because it is not stitched together. It is braided, so that means that the individual toes are still able to slide past each other, which means it's highly drapable and conformable, as we're showing here today, to this dome shape. It's also highly infusible, and that's again because it is triaxial in a single layer. Our bias fibers span from the top down to the bottom of each ply, and that creates through thickness resin infusion channels that allow air to evacuate easily and the resin to be infused. It's also great, the fact that it is quasi-isotropic means that there's no rotated plies needed. It's the same in every direction around. Which means that you don't have to rotate plies and all of the scrap associated with doing that. Standard product Qisos are offered from about 270 GSM up to 1100 GSM, and then we can customize really anywhere in between. If there's a particular aerial weight you're looking for or a particular cure ply thickness, we can really right size the product to be exactly what you want in terms of thickness, but then also in terms of width. So if you need an 18-inch wide ply, we can produce the Qiso at 18 inches, and that helps to cut down on scrap associated with cutting your plies and any scrap on the edges. Thanks, James.
Just going to touch a little bit on this silicone bag that we made. A couple years ago, we did a preform demo, basically with the same material, but we used a bagging film and a heat gun to activate the glue. As Brandon mentioned, the glue needs to activate at about 220 Fahrenheit. This year we decided to try something a little different, so we made a silicone bag with a heating element in it. Right now I'm about close to 200 degrees, but we conquer two things with this at once. We're able to put the bag on, pull vacuum on it, consolidate all of our material. Then we can put the heat to the bag, melt the glue. Hence, we'll have a preform when this is all said and done. So we're heating up. We're going to leave this on for a few minutes longer, and then we're going to be able to turn the temperature down and let the bag cool off. We'll leave it under vacuum through the demo and pull the preform off at the end of the demonstration.
Thanks, Dan. So I mentioned so our preform tool is just a low-cost material. Our production tool is actually built out of aluminum, and it's a multi-piece tool. As I mentioned, it's temperature controlled, so we have pressurized water running through the tool to heat and cool the tool. So we can run really quick cycle times to heat up and then cool back down. We have a large flange around the tool so we can seal our process materials. You can see there's sealant tape already on the tool. But I'm going to go ahead and let Adam from Origen talk to you a little bit about the tooling and how it's special for this process.
Thank you, James. I'm Adam Elsmore. I'm from a company called Origen Manufacturing out of Ogden, Utah. And we all know that when you're producing parts, your parts are only as good as your tools. And we're a firm believer in being able to produce the best tool possible before you even begin the process of manufacturing. When Composites One approached us about creating this tool, we went through their design parameters, and we came together with them and decided to go with this self-heated pressurized water tool. As James mentioned, it is a two-part construction. It has a sandwich structure, as you can see in the slide. We create a separate plate, a base plate that is out of 6061 aluminum. We obviously have a scale factor, and we always need to take into account the temperature delta when we're producing these tools to get our dimensional accuracy. Once we go through that design process, we take into account the stresses involved with the pressurized water system, and we design the circuitry. We basically have a water feed in, a water feed out. It's a very simple system. It's very friendly to use, and it's also very scalable. With this system, you're able to scale up multiple tools, but furthermore, you're able to reduce cycle time. Speaking to Barry, he was able to take his cycle time down from 2.5 hours to under 40 minutes. So it's a significant cycle time improvement. And with this tool, once we get through that design phase, we design the circuitry, we design the sandwich plate, and then we take into account the fasteners and the sealing surfaces as well. We seal the tool, we anodize the tool as well for surface finish. Our focus at Origen is to get surface finishes out of the machine as good as possible to reduce any handwork that's associated with mold surfacing. So that's one of our expertise, or one of our specialties is getting extremely good Class A surface finishes out of the machine. With this tool, again, we love the footprint, the scalability, and then also the ability to cool. As James mentioned, you're able to heat the tool at a very controlled ramp. You're able to maintain temperature thresholds if you want to dwell. You're able to do that. That can be programmed into the machine. You can have TC feedback into the system as well. And then you can also reach your final temperatures quickly. Once the part is cured, you're able to dump that temperature by using the cooling circuit, which is basically just a reverse flow. And then you're able to cool the tool very quickly, and then you're able to cycle your part. From that point on, you're able to repeat the process, and you can fine-tune it, and you can really work a significant amount of cycle time out of the process. Again, at Origen, we enjoy these challenging projects, and we enjoy being able to design and produce this type of tooling. For anyone, if you have any questions, feel free to reach out to myself or Scott with the Origen shirt afterwards. Thank you.
Thanks, Adam. All right, so we've transferred our preform from our preform tool to the temperature control tool from Origen, and so they've already started loading process materials for the infusion process onto the tool. And so Doug Perry Hunter is going to tell you more about the process materials they're using for the process today.
Yeah, thank you, James. So today, you'll notice that the guys, whenever they've loaded the preform, in direct contact with the laminate, they'll have Infuply 2, which is a combination material for flow media. It has a knitted mesh and then a hot perfed release film on the back side of it, so that way they can load it very quickly. It is highly conformable, being with the knitted mesh. And then on the periphery of the laminate, they've also got a red stripe peel ply. And that nylon peel ply helps with resin distribution and also part impressions. So if you need a surface that maybe is going to have some secondary bonding and those type of things, is generally where we'll see the most usages for peel ply. And then, of course, around the periphery of that, you'll see a 10-ounce nylon breather to help for air communication. And if you also notice that they have overlap, so that way you have consistent airflow across the part. And then outside of that, they've got the Holcim 5142 sealant tape, good to 400F, and so that way they can get a good tight airtight seal. And then they're encapsulating all of that with StretchVac 4000, which is a co-blended nylon film, good to 400, a little over 400F, and it has a really high elongation. It's a fantastic vacuum film for major cure processes, oven, autoclave, and obviously infusion.
Thanks, Doug. So a little bit more about the process, the infusion process, if you're not very familiar with it. It's driven by Darcy's Law, which has several different variables. We have the resin viscosity, we have the vacuum pressure or the atmospheric pressure, and we have how far we're going to flow. So one of the things with the temperature-controlled tooling, we actually have the tool set at 90 degrees Fahrenheit. So the show hall today is about 75 degrees, so we can warm our tool up a little bit better, and that's going to help the resin flow, because the resin viscosity depends on the resin temperature, and in the infusion process, the resin temperature is going to be whatever your mold temperature is. So the higher the temperature, the lower the viscosity, the better flow you're going to get, and the better wet out. So there's a number of different strategies in the vacuum infusion process. This is a fairly small part we're doing, but we do have a fairly dense carbon fiber preform. Brandon was telling us that the braided material works well for infusion, but carbon fiber in general, the actual fiber diameter is very small, and so the fiber bundles pack together very tightly. So you need a little bit more time for the resin to completely saturate the fiber bundles and completely encapsulate each one of those fibers. So the strategy they're using today, they're going to pull vacuum around the perimeter. So the white breather material that's on top of the peel ply is going to provide vacuum to the part. As Doug mentioned, we have the blue InfuPly material on top, and that's going to provide resin flow across the top of the part, and then the resin's going to permeate through the thickness of the part to the mold surface. We're going to introduce the resin in the very center of the part. We have a very small spiral wrap tubing to transfer the resin along the longitudinal axis of the part and into the InfuPly. And one of the things we've done on this part, since it's so small, we really want to control the flow. So we're using fairly small diameter lines to throttle the resin a little bit. But basically, they have the flow media, and you'll notice it doesn't go all the way to the edge of the part. We have kind of a resin break, if you will, so that the resin along the mold surface and in the InfuPly can catch up, and we won't have any lag between the top and the bottom. And then our peel ply provides sort of a resin stopper to slow the resin down so we don't pull all the resin out of our part. So Dan and Barry are putting pleats in the vacuum bag. The vacuum bag's oversized by about 20% to allow it to conform completely to the mold. The SV4000 material has very high elongation, but we don't want to rely on that elongation to get into the corners, because otherwise we could have bridging. If we have bridging in the corners, we're going to have resin-rich areas. In the process, they could cause high exotherm, and in the final part, it could lead to brittleness in the part. We're already starting the vacuum, so it's going to draw the bag down, and we're going to be infusing it at full vacuum, so 30 inches of mercury, which will consolidate that preform and give us a very high fiber volume. But I'm going to let Tom from Polytek tell you a little bit about the infusion resin we're going to be using today.
Perfect. Thank you, James. Yes, my name is Tom Augustiniak from Polytek Development Corp., CPD. We're a manufacturer of specialty epoxy systems, both on the resin and hardener side. For this particular demonstration, we're going to be using the CPD 4281A with the 4284B. As you see on the chart up there, it's the first one on the top, which is the 40-minute gel time, 150 centipoids mixed viscosity. And as you see, there's universal resin with all different hardeners depending on what gel time you need, heat deflection temperature, and viscosity. So as we're doing for this smaller part here, we want to cure quickly so we can mass produce parts multiple times a day on the heated tool. So that's why we're choosing our fastest system. In addition to other hardeners that we have to offer with this resin system will be for toughen, core shells, as well as FR properties as well. A little bit about Polytek too. We also have other systems that are hand lamination, compression molding, and the infusion. So for this demonstration here, we will be using the 4281, 4284, and with the low viscosity, it will infuse very quickly once we do turn the pump on to start pulling from the cup. Very good.
Thanks, Tom. So now Barry and Dan are just doing their final leak checks on all the pleats. In the vacuum infusion process, you need a leak-free bag, and so they're going around just making sure there are no leaks in the pleats. That's where they would tend to occur in the sealant tape, and just do a final leak check before we start the infusion process. So you'll notice one of the other features we have is we're using a resin infusion connector. So it's this blue little cone-shaped piece in the part. And that goes on underneath the bag, sits on top of some breather, and allows us a nice connection to our vacuum hose in this case. It can also be used on the feed side to introduce resin into the part. And it's made out of polyethylene, so it's reusable, and can be used several times in the process. Some of the other infusion strategies you could use is we could actually feed this around the perimeter and pull vacuum in the center of the part. One of the challenges with that is if you have any leaks around the perimeter, you'll be leaking air into the part where you're introducing resin. And we don't want to have any air in our part. So that's why we pull vacuum around the perimeter. So we're going to go ahead and mix the resin. They've done the final leak check and approved the bag. And so we'll mix up the resin, and once that's fully mixed, we can open it up and introduce the resin in the part. That's one of the great things about the vacuum infusion process is we have a virtually unlimited setup time, so we can make sure all the fibers and process materials are placed correctly and not have to worry about the open time of the resin until everything is fully approved. So Barry has actually increased the mold surface temperature to 110 degrees Fahrenheit. Our resin is mixed, and we're going to open the feed line, and you'll be able to see the resin flow through the InfuPly. And then there's a slight lag between where you see the resin flow in the InfuPly and where the resin is on the mold surface. And that's why we have a resin break around the edge of the part. So you can see the resin flowing through the InfuPly, and it's permeating down through the perforated release film. And on the mold surface, we're probably a couple of inches behind where the resin is saturating the preform. So once we get to the edge of the InfuPly, the resin will slow down significantly, and it'll start to saturate the preform through the thickness. You can see the resin flows very fast. Once the resin's probably about 75 degrees in our cup, but then once it hits the mold surface, it's going to quickly climb up to the mold surface temperature, which we're at 110 Fahrenheit right now. So after the infusion, we can ramp the temperature up even further, have the resin gel, and we could even post-cure it on the mold, and then cool it back down to our demold temperature. So the InfuPly has filled completely. We're just filling the last parts of our preform, and it's only been a minute and a half for the infusion process. So we do have some runoff you saw on the preform. So we have some runoff that will be trimmed off the part at the end, and then the part's pretty much done. So that was a quick run through of the vacuum infusion process with epoxy resin, carbon fiber braided preforms. We'll ramp the temperature up, cure the part, and we'll demold it a little bit later. Thank you for your time.